All right. Our second panel today is on the topic of sensing the environment. This is a topic that brings together unique advantages and unique capabilities here at UCSD, capabilities that are represented in the computer science department, the engineering school, the supercomputer center here, as resources for being able to deal with all of the sensing data that we're going to hear about, and then the unique resources of the people sitting here at this panel and all of our collaborators and colleagues that every one of us works with. So let's start with no further ado. Kim, you want to start out?
Okay. Today in 7 minutes. I thought I had 9 last night, so I added a couple slides, and then I got them taken away this morning, so I hope your seatbelts are on. I want to talk today about the center that we've just launched, at least the phase 2 side of it, which is called the Center for Aerosol Impacts on Climate and the Environment. And this is a 5-year, hopefully 10-year, $20 million, hopefully $40 million center that focuses on a really important problem. Ralph talked about greenhouse gases, and what we're focused on is the aerosol side of things. And so I just want to give you a tiny flavor of where we're going. And if anybody's interested or has aspects, by all means, we are just launched as of October 1st. And so I'll start because they said it was like a TED Talk, and what is an aerosol? And yeah, this is a Mac to PC thing because my spray, it's completely gone. Okay, so there was a spray can, and the spray can gets an X through it. That is an example of an aerosol, but that's not an example of the type of aerosols that we're studying. What we look at, and it's also not here, is basically the dust and sea spray, which are natural sources, which blanket our globe, can circle the globe on time scales of days to weeks. So aerosols are really complex, and Ralph mentioned, you know, the atmosphere has no walls, everything moves around. And so when you think about pollution, it really is a global problem. And aerosols are tough because spatially they vary so much depending on where you are. They vary in space, they vary in time. And so when you talk about a measurement challenge or big data challenge, this is it. These are examples of different anthropogenic or human-induced sources. In California, the 2 biggest ones for us are, well, 3 actually, wildfires, depending on time of year, ships, and vehicles. So how do aerosols influence climate? They are really complex in their chemistry, and that's why I should mention, this center is what's called the Center for Chemical Innovation. So it has an innovative component, it has entrepreneurialism, it has students communicating science, and it basically focuses on chemical complexity because that's what their aerosols are. Depending on their composition, aerosols can warm or cool our planet and offset greenhouse gases by some amount. We do not know how much. And so it really comes down to understanding what the chemistry of these complex systems is and how that ultimately controls their impact on climate. They can impact climate through direct interaction with sunlight, so they can reflect light back to space, which means it doesn't make it down to be absorbed by the greenhouse gases, so that's how they offset it. But things like soot can absorb the light and actually induce extra heating. And so, again, keeping track of what is what, it ultimately comes down to chemistry. But one of the most important aspects of aerosols is how they seed clouds. At the center of every cloud drop, at the center of every ice crystal, is a particle. And not every particle will form a cloud drop or an ice crystal, particularly ice crystals, very chemistry selective. And so it turns out that if we could understand why clouds form, these are what are keeping our planet cooler. And it represents the largest single uncertainty in our understanding of climate change. And so that is a big, big focus of our center. So just to give you a little feel, there's sort of the global aspects of climate, but then there's also, one of the things aerosols do is they affect things very, very strongly on a regional effect. And so this just is a paper that we published this last year in Science on, we went out and our snowpack, as you saw earlier, I almost showed that same figure, has decreased dramatically. And that's our water storage for California. So these are really serious times in California. And so we were going out looking for how our own pollution was reducing the amount of rainfall we were getting in Northern California. And in the snowpack has been decreasing. But what we found instead was that during days where you had long-range transport from as far away as Africa, we could actually see the extra snow falling at the ground. So this was the opposite of what we were actually looking for. And again, it comes down to a chemical effect, and it hints that chemistry is important. But there's still very fundamental aspects of this process that we do not understand. So the center that we've developed has basically, the step what we said, okay, we've been doing field studies. I've been doing field studies for 22 years. We do lab studies. We try and mimic things in the lab. It's really tough in this complex of a system. So we said we're going to bring the real world and put it in the lab where we can control things and really go after this problem. And let's start with a simple system like the ocean and the atmosphere. That's simple, ha ha ha. But it was, basically, in all seriousness, the ocean and the atmosphere, this is the perfect place to tackle this system. We have people who've been studying oceanography for decades. We have people who've been studying the atmosphere for decades. We just needed to work together, and that's what this center has allowed us to do. It's a collaboration between chemistry and physical sciences with Scripps Institution of Oceanography, and this is the complex system that we are striving to measure by getting the right physical oceanography, the right marine biology, and then finally studying the chemistry. So why at UCSD? It's pretty obvious. We've got the ocean right here, which is where we started. We've done many, many cruises. Again, we go out, we observe things, but just that fundamental understanding has been lacking. So we can control things in the wave flume at the hydraulics lab at Scripps. And then we've even developed these little mini sea spray generators that we can run in the chemistry department and do phytoplankton blooms and induce marine biology to happen. Turns out microbes are very, very strong in controlling, trying as hard as they can to sort of control our climate. We have a long-standing tradition in these areas. We have the infrastructure that nobody else has, and we have people in the right areas. The key was to really thread them together, and that's what we've been able to do. And so we've successfully brought in the ocean. It's natural water, seawater. We can break waves in a controlled manner. Our physical oceanographers make sure we do it correctly. And then we can do controlled marine biology, which the marine biologists make sure that we do that correctly as well. And so we now have this unique system. It's the only place in the world where sea spray is being properly generated in a controlled way, where now we can control the knobs and look for change and understand the fundamentals. The last thing I want to talk about just really briefly is we're focused on climate, but when you get a center like this of this magnitude, my hope is, and everybody's hope is, that we can actually just seed other opportunities. And one big opportunity is aerosols are well known to be very major players in health. But again, our understanding of how they impact health is almost as poor as our understanding of how they impact climate. So aerosols transport things into our bodies. They bring in toxins to regions that nothing else takes them there. They can get to every region of our lung, our hearts, our lungs, even our brains. And so the teeny tiny ones can get into our bloodstreams. And so they're having these huge effects, but we don't really understand. And with the School of Medicine and other, the engineering school, as far as understanding concentrations, there's just, I think all the players are here to make a real difference on this problem. So the last thing I'll mention is that, this is another large-scale environmental problem, this being climate. We've had another one we've dealt with where you really need to tackle all aspects of the problem, and I really think that UCSD has every single one of these boxes. Some boxes need a few more participants in particular aspects. Modeling, I agree, was mentioned earlier, and we really do need to think about that more. But how do we go from end to end, all the way from understanding the fundamentals at a predictive level to actually coming up with solutions? And so the last little pitch in answer to questions about what could we do with a little institution support, one thing that's been I would say a challenge in the 12 years that I've been here is the facility support. And I think facilities, in addition to students and personnel, are the glue that naturally bring faculty together. And I think we're in position here to be leaders in chemical imaging. And so I'll just say these are the critters that we've been able to image. This is work done by Nathan Janeski's group in our department, but this is cryo-EM images of little vesicles that exist. There's amazing structures that exist in the ocean and the microlayer, ultimately are getting out and impacting our climate. And so again, driving these tools is a big part of the center that we've developed as well, and I hope that the institution will recognize that that's a really nice way to bring people together. And with that, I'll stop. Thank you.
Great, thanks, Kim. 8 minutes, that was good. So, question over here.
Okay, honestly, less so a question than a comment that I wanted to make, but I think the segue is really nice with everything Kim talked about. I want to make 3 quick comments about honing, sort of selection, honing the message, and institutional support. I think in terms of sort of honing the right types of projects, I think we have to look beyond institutional support and without giving up our academic freedom, looking at what are national initiatives, what is the government funding, right? Because that's going to bring sustainability to these projects. And I think CASE is a perfect example of that, right? It both brought people together, but provides a model of sustaining these types of efforts beyond a campus seating. The other two things I just want to quickly say is in terms of support from the institution, I think that a little bit more support in terms of bringing and helping facilitate the preparation of these types of grants would be one thing. I know that your office already does that, Dr. Brown, and I had an excellent experience with Sharon Franks in doing that with a recent EFRC center. And I think that kind of support and expanding that and actually making faculty more aware of those cross-cutting opportunities, because I can't keep track of all the federal calls, would be very helpful. And the last thing I'll say very quickly, just in terms of inclusion and building bridges, I'm always impressed by how Kim and SIO is so good at engaging economics and outreach, and I think that this is a real challenge for other sciences. And so in the spirit of inclusion, I don't have an answer for it, but how to get an economics faculty member to better help someone in my department who's doing organic synthesis or biochemistry. Again, I don't have an answer for it, but I think that would be a huge leap that nobody else is doing, getting those types of people together in an effective manner. You guys do it well, and I think that's because the same reason you see programs about this on NOVA, but it's harder for something like biochemistry or inorganic chemistry, for example. So anyways, I'm sorry to take up too much time, but.
Great. Do we have other questions? Kim, I have a follow-up question. One thing that caught my eye was your bullet on understanding human choices. That could be interpreted two different ways, understanding the impact or understanding what motivates people or incentivizes them to take certain choices. Have you thought about this?
I've thought about it, and I don't know the solution. I think that I put that there because I think it is, in thinking through the strategic plan, it is something, again, that we have on this campus. And the way, I honestly, coming at it as a scientist, I've always thought, okay, the hard part is just knowing what's affecting things. That's what I always thought. And then I've just over the last couple of years have started to really, just watch. I do a lot of public speaking, and it is going to come. Whether we can solve or when we solve this problem, I should say when. When we solve this problem, it's going to hinge on people's choices. It's not going to hinge on whether we can measure the right things or model the right things. It's going to be the people. So we need to be working on those things in parallel. So I've come to appreciate that aspect a lot more over time.
Yeah. All right. So that's a timeout for our speaker, Kim Prather.
By all means, we are just launched as of October 1st. And so I'll start because they said it was like a TED Talk, and what is an aerosol? And yeah, this is a Mac to PC thing because my spray, it's completely gone. Okay, so there was a spray can, and the spray can gets an X through it. That is an example of
these that are represented in the computer science department, the engineering school, the supercomputer center here as resources for being able to deal with all of the sensing data that we're going to hear about, and then the unique resources of the people sitting here at this panel and all of our collaborators and colleagues that every one of us works with. So let's start with no further ado. Kim, you want to start out?
Okay. Today in 7 minutes. I thought I had 9 last night, so I added a couple slides, and then I got them taken away this morning, so I hope your seatbelts are on. I want to talk today about the center that we've just launched, at least the phase 2 side of it.
All right. Our second panel today is on the topic of sensing the environment. This is a topic that brings together unique advantages and unique capabilities here at UCSD. Which is called the Center for Aerosol Impacts on Climate and the Environment. And this is a 5-year, hopefully 10-year, $20 million, hopefully $40 million center that focuses on a really important problem. Ralph talked about greenhouse gases, and what we're focused on is the aerosol side of things. And so I just want to give you a tiny flavor of where we're going, and if anybody's interested or has aspects,